Dear students, welcome to the next session of wave optics. Today I am going to explain Young's double slit experiment, some questions and its answers. Let us start now. The question number 1. In Young's double slit experiment, the central bright fringe can be identified. Here 4 option is there. You can see the answer here. It is first one, white light instead of monochromatic light. As you know, the monochromatic light and the white light difference. In monochromatic light only single wavelength light, and white light is a combination of different wavelengths. So in a double slit experiment, you can see the two sources, like it is coming from one source and we are splitting into S1 and S2. This is the main source, then the light is coming like here, and this S1 and S2 as two sources, and a certain distance we are placing one screen. Here the fringes will appear because of the light wavefronts, like it is like wavefronts. Light is, as per Huygens theorem, you know that it is traveling as waves, so the wavefront will be generated here, light, and here also wavefront will be generated. So here you can see both waves. This is here and this is going to here, and this is coming here, this coming here, this coming here, like this. Here bright, dark, bright, dark, like that the fringes will develop. So in a monochromatic light, all waves are wavelength are equal, but in white light different wavelength, so the central bright can be identified. The central, here will be the central bright in the middle of this one. It will be identified in white light, and in the other sides, in the going in this direction, in the other direction, there will be some color difference, depends on the wavelength. You know, in the white light, VG or this much color combination will be there. So a small variation of red color adjusts, and it will be like bright color will be in the center, and the other sides it will be some changes will be there. Center fringe will be the white with the red edges, and so on the other side, either side of it we shall get few colored bands and then uniform illumination. So the answer will be, the first one is the answer. Okay, let us see the second question. In this question, Young's double slit experiment, how many maximas can be obtained on a screen including central maximum on both sides of the central fringe? The lambda and d also d are provided. Okay, as you know, this double slit experiment, here the source 1, the main source is this one, and this is source 1, source 2, S1, and this is S2. So as you know, the fringes will be developed here. In the screen the fringes will be white dark like that. The fringes will be obtained here. So D is provided here. D is equal to 7000 Armstrong into 10 to the power of minus 10 meter. This is the D. This distance is the D, and wavelength lambda is provided 2000 into 10 to the power of minus 10. Okay, as per the equation, this is D sin theta equal to n lambda. Sin theta equal to n lambda divided by d. If you substitute the values here, sin theta will be n divided by, here d lambda by d, that is 2 by 7 into 2 by 7, that's equal to n divided by 3.5. okay, so sin theta is equal to n divided by 3.5. as you know, the value of sin theta will be greater than or equal to 0 and less than or equal to 1. So here it is 3.5. so n divided by 3.5, for what values n, the theta will be in between 1 and 0. Let us take n equal to 0. If n equal to 0, 0 by 3.5 is equal to 0. So sin theta is valued. Sin 0 is equal to 0. So if n is equal to 0, it's okay. And if n is equal to minus 1, so what will be the value of theta, sin theta? If n is equal to 1 divided by 3.5, so that means the value is less than 1. The sin value will be less than 1. So that's also correct. And if n is equal to 2, n is equal to 2, n divided by 3.5, and n divided by 3.5, 2 divided by 3.5, that also less than 1. So it also correct. 3, if n is equal to 3 by 3.5, that also less than 1. So that also correct. Similarly, in the minus value, as you know, the sign values here, I'll draw here. The sign value will be appears like this. So sign 90, sign 0, here minus 1. So from minus 1 to 1, here it is 0. So how many value will come in between minus 1 to 0 and 1 plus 1? So including 0, here you know 0, 1, 2, 3, 1, the value 1, value of n is 1, 2, 3 is coming in between 0 and 1. Here also value 1, 2, 3 will come in between minus 0, minus 1 and 0. So total here 3, here 3 and central value. Okay, 3 plus 3 plus 1, total 7. So the answer is 2. Okay, next question 3. In this question you can see a double slit experiment is performed with a light of wavelength 500 nanometer, a thin film of thickness 2 micrometer, then refractive index 1.5 meter is introduced in the path of the upper beam. The location of the central maximum will be, see here what is explained in double slit experiment. Yes, we explained earlier. This is in the double slit experiment, source 1, from source 1 and source 2 the light is traveled from wavefront like this, and this is the waves travel, the light is travel here also like this. What is mentioned here, the light wavelength of lambda is already provided here, and what extra is explained, the thin film of thickness 2 micrometer and refractive index 1.5, and here it is placed one thin film. This thin film, suppose this is the thin film, the light will be coming like this, will be the path will be changed to, normally the path will be like this, but it will be changed because of the refractive index, different refractive index, and that means here if we place this thin film, the normally light will have to go like this, but the path difference will happen like this. So the formula is equal to extra, we have to calculate the path, the location of central maximum, what will be the thin film and the refractive index introduced in the path of the upper beam. The location of the central beam will be what shift will happen in the, how much shift will be happen in the beam. So the extra path difference, difference equal to, extra path difference equal to mu minus 1 into T. Here T is the thickness already provided here, 2 micrometer, and the refractive index is 1.5, that is 1.5 minus 1 into T. 1.5 minus 1 into T is equal to 2 micrometer into 10 to the minus 6. So that will be 0.5 into 10 to the minus 6. So the answer is 3. Shift upward nearly 2 times. That is, we have to calculate. We have the formula n lambda is equal to 0.5, that is mu the refractive index mu minus 1 into T, that's equal to 0.5 into 10 to the power of minus 6. Shift is equal to n fringes. If it is n fringes, n is equal to, here you can see n is equal to mu minus 1 into T divided by lambda, that is this one. So that's equal to, if you substitute the value here, it will be 2. The answer will be 2. 1.5 into 2 to the power of 6, 5000 into 2 to the power of 9. This lambda is equal to 500 nanometer. So that we are calculating this one, we will be getting the value of n equal to 2. So n equal to 2 means the path difference here, it is 2 fringes in the direction of upward direction, because it is in the upper beam. So since the thin film introduced an upper beam, see, the shift will be upwards. So to shift upwards by nearly 2 fringes, that is the answer. The option number 3 is the answer. Okay, next question is question number 4. In Young's double slit experiment, a mica slit of thickness T and refractive index mu is introduced in the ray from the first source S1. How much distance the fringes pattern will be displaced? It's also almost the same question just before we did, that is the fringes pattern, how much it is distance it is displaced. Here also the same experiment. The screen is here, source 1 is here and source 2 is here, and D is the distance of the screens, and slight distance is equal to D, and the light is going like this. So here we place one, in between we place one mica slit of thickness T and a refractive index mu. So here the displacement delta, suppose the delta x equal to mu minus 1 into t, that is the path difference. We the previous question we did this, that's equal to y d divided by d. So the distance, the fringes pattern, how much the this, let y be the number of fringes pattern, distance, how much distance the fringes pattern will be displaced, number of fringes pattern we are taking is as y. So it is y is equal to mu minus 1 into t by d into capital D, here d minus 1 by minus 1 into t by d, that is the answer is 2. Okay, so the fringes pattern will be displaced by this much, d, capital D by d. Here capital D is the screen difference and d is the slit difference, and mu minus 1 into t, mu is the refractive index and t is the thickness of the mica placed in between. So this is the answer. Okay, next question, fifth one. If a transparent medium of the refractive index mu is equal to 1.5 and the thickness t is equal to 2.5 into 10 to the power of minus 5 meter inserted in front of one of the slits, Young's double slit experiment, how much will be the shift in the interface pattern? The distance between the slit is 0.5 meter and then that between slits and the screen is 100 meter. So what mentioned here, you can see here what is provided, what are the things provided. The media and transfer media refractive index 0.5, 1.5 mu, refractive index 1.5 and the thickness 2.5 into 10 to the, means here the, as we did the previous example, the mica sheet, a transfer medium of refractive index, transfer medium is placed in between in the beam, so it will be change, the path will be changed here. The micro mu is equal 1.5 is the index and the thickness is 2.5 into 10 to the power of minus 5 meter. Interference pattern, how much shift will happen? The distance between the slit is 0.5 nanometer, that is this is the slit difference, this is two slits, its difference is 0.5 millimeter. Here it is 0.5 millimeter. 0.5 0.5 millimeter, and the distance here in between the screen is D, that is 100 centimeter, equal to 100 centimeter. So the shift pattern x is equal to mu minus 1 into d by d. This formula we already used the previous question. The shift in the fringe pattern will be mu minus 1 is equal to refracting index 1.5 minus 1 into 2 to the power of 10 to the power of minus 5. That is the thickness T, and D is equal to 100 centimeter. 100 into 10 to the power of 2, and this D will be D is provided here 0.5 millimeter, that is 0.5 into 10 to the power of minus 3. After calculating this value, we will get 2.5 centimeter. That is the answer to option 2. Okay, that's it. Thank you for watching.